Hello and welcome to the TechBrain channel. In this video, we look at index-covered queries, a performance tip that you will find useful when using indexes in MongoDB. Let's look at a typical query. This typical query will have an index, but there are ways that I can actually optimize the usage of this index. Assume that I have a document with the following structure. We'll keep the document fairly simple. We'll say that this document has non-array fields with the following values. We'll then insert that document into a collection. Insert one, pass the document in, and we write a query where we try to find the document based on the value of the field B, for instance. B is equal to 34, and we perform a sort on the field A in descending order. If I look to explain how this query is running, and we can do something like explain with execution stats. And go for execution stats as well. What we notice is the collection is scanned. As the collection is being scanned, we've got a filter that's being applied, and that filter is B is equal to 34. The results are then sorted, and we return one document. There are no keys examined, documents examined one, and execution time was sub-milliseconds. So this is not an optimal stage for my query. Neither is this. So what I'll do is I'll create an index. So my index will take into account the way that I'm using these fields. So I have a field that performs an equality. I've got a field that performs a sort. Let's create the index. So go to db.example and we say create index, and we've got equality field, which is B ascending, followed by A in the same order that would like things to be sorted, which is descending in this case. So we have created our index. Let me rerun our query. We'll notice that we scan the index this time around. We're actually scanning through the index. As we scan through the index, we're looking for a document with a value B is equal to 34. The other thing we notice is that there is another bit of I/O happening. We need to fetch the document from the collection. Is it possible to eliminate this additional bit of I/O? If we do that, it would make this query faster. So what's the technique I can do? What's the technique I can apply to achieve that? So there is something called an index covered query in MongoDB. So this is a query that I run with an index, and I only have to access the index to retrieve the results. I don't need to perform any additional stages. So what I'll do is I'll introduce what we call a projection in here. So that's my projection. You'll say, yep, projection. And the projection is really just to say, and these are the fields that I want to see. So one of the reasons that we have to fetch is that we need to return _ID. So if underscore ID is not required in the output, I can actually leave it out using a projection. So I'll say underscore ID is equal to 0. And also I need to tell MongoDB the fields that I actually want to see. So I'd like to see the fields A and also the field B. So those are the fields I'd like to see. Let's look at the explain output when we do that. So the explain output now shows us that we only access the index to satisfy this query. So we've been able to eliminate additional I/O. Used properly, this can actually improve the performance of my system, or other things, being taken into account as well. I need to make sure that I have sufficient resources on this platform and that things are generally running okay. So I have an index covered query. We only ever need to access the index or scan the index to get the results that we need. What can break this? There is a limitation with this kind of index. If I suddenly start adding arrays to my documents, let's say I come here and maybe instead of b equal to 34, I have maybe b is equal to an array with a value of 34. If we return arrays, that will break an index covered query. So one thing to notice here is that the current index is not a multi-key index. If we look at this bit here, the current index is not a multi-key index. Is multi-key is set to false. The minute I introduce an array field in any of the values there that are in the index, this becomes a multi-key index. So if I insert the doc and then rerun my query, notice that we're now dealing with a multi-key index and it's no longer a covered query. So there is now a fetch stage, as you can see there. So we went from an index covered query to something where we actually need to fetch stuff from the collection. If I go here, we can look at the visual explain plan for that query. I'll run my query. So I was looking for b is equal to 34, and then stick some options here where we sort on the field A in descending order, and then we get to explain it. So we can see there's an index scan and then a fetch. Previously, we only had a scan of the index, and what has broken this is the fact that we're now dealing with what is essentially a multi-key index. Is multi-key set to true? So your index covered queries will break if you introduce array fields. They will no longer be covering indexes. So just be aware of that. Otherwise, if I use this carefully, it can actually improve the performance of my queries. So that is index covered queries. Thanks for watching, and until next time, bye bye.